In this second part of the review videos for Unit 7, I'm going to look at numbers 9 through 12, most of which are dealing with angles and arcs and the relationships in these circles. In number 9, I give you that circle O, in circle O, measure of, and when you look at this, you've got to know right away that that symbol means arc. Measure of arc FG is 98 degrees, which they've labeled right here. So when you're thinking about that arc, that's this piece of the curve right there. And the measure of arc DG equals 158 degrees, so they've labeled this one, there's DG 158 degrees. So remember, these arcs are the distance in degrees along the actual circumference of the circle. So in part A, they've given you 4 parts that you have to try to figure out. The first one, arc DF. I'm going to look at this one first, which is right here. Now, if you look at the 2 they gave you, remember that 98 was FG, 158 was GD, DG, and so notice that the entire circle is now highlighted, so the 3 arcs that the circle is split into actually make up the entire circle, which means that they all add up to 360 total degrees. So to get arc DF, you have to take the 98 and the whoa, that's a good looking 8, 98 and the 158, and you have to add those together. And you get that 16, let's carry the 1, and that's 256 degrees. And then to get that remaining arc, you have to take the 256 and subtract from 360, which gives you 104 degrees. So the 104 degrees, there's your arc DF. Part B asks for the measure of arc DFG. DFG now with 3 letters is a major arc, so starting at D, going through F all the way to G. Now remember, we just solved for DF, that was 104 degrees. So all it is taking those 2 measurements, the 104 and the 98, adding those together. So 104 plus the 98, and you should get 202 degrees. Yeah, so arc DFG is now 202 degrees. Part C, now they ask for a different part, and look at this symbol. Remember, that means angle, so the measure of angle DOG. So now if I'm looking at angle DOG, I'm starting at D, going to O, and going all the way over to G, so it would be this angle right here. Now notice that the vertex, that middle letters at O, which is the center of the circle, and when you have that happen, if you have a circle and you have this angle from the center, it means that this arc is the same as the angle. They have the exact same measurements. So we know that this 158 now goes with that angle. So that angle DOG is 158 degrees. The last one in number 9 we have to find is measure of angle FOG, which is right here. That's the angle we're looking for, and notice that it intercepts that arc above it, arc FG, which is 98, and again, central angle, so it's exactly the same. So that last measurement, angle FOG, is 98 degrees. In number 10, there's one typo in number 10. It says given the secant segments, so this should actually say tangent segments, because this line and this line are tangents to the circle. It says given those tangent segments, find the value of x. And this is a pattern where this angle that's created here, this angle 86 degrees, is outside the circle. And you might have seen a different formula for it, but when you have that happen, when you have an angle outside the circle, whether they're made by tangents or they're made by secants or they're made by one tangent and one secant like that, the formula that works for all of them is taking 2 times that angle, 2 times the outside angle. That is beautiful writing. Let me try that again. 2 times the outside angle, and then putting it equal to the big arc that the angle's sides make up, subtracting the little arc. So in this particular example, that angle that's outside is the 86 degrees again. So this is the angle that's being doubled. So when I start to plug in, it's 2 times 86 degrees equals. Now the big arc is the big arc that's in between the side, those two tangents. That's your big arc. So in this case, that happens to be x, so big arc will be x, minus the little arc is this curve that's inside, that's between the tangents, which is labeled as 40 degrees. So now I'm trying to solve this for x. I'm going to take 2 times 86, that's 192, equals x minus 40, and then to isolate the x, I'm going to add 40 to both sides. And that gives me 232 degrees for x. So number 10, x is 232 degrees. Number 11, we're continuing work with all the angles and the arcs. And you'll notice underneath part C, there's 4 choices on your paper. It should not have been multiple choice. You can just go ahead and cross those off. So I'm going to look at parts A, B, and C here. Now again, it says use angle circle C to find the measure of angle ADB. That is one of 3 things we actually want you to find here. In part A, the first thing we're asking for is the measure of arc AB. So as soon as you see that symbol, remember that means arc. So arc AB is this one right here. Now one of the hardest things to see on these pictures is the fact that AB, that arc, is intercepted by this angle. And whenever that happened, whenever you had a circle that had an inscribed angle where the vertex is on the circle like that, it would intercept this arc. Let's call it A. The pattern is you would take 2 times whatever that angle is to get the arc. You don't have to worry about addition or subtraction here. It's just 2 times the angle equals the arc. And so it depends on what you're given. But here is nice and easy because in this one you're given that that angle is 81 degrees. So all you have to do is take 2 times 81 to get the arc. Multiply those, you get 162 degrees. There's arc AB. So I'm going to go ahead and label that also here. Then part B, I see to find the measure of angle of arc ADB. So now I'm starting at A, going backwards through D all over to B, and notice that the highlighting I just did kind of covered the rest of the circle. So now all I have to do is take 360 and subtract the arc I just got. 360 minus 162, that's 198 degrees. I think I did that correctly. So then arc ADB is 198 degrees. I'm also going to label that over here. The last part they want you to find is in part C, the measure of angle BCA. Remember, this notation means angle. Angle BCA, C is the vertex of the angle, which is at the center of the circle, which is the same as the arc that it intercepts. So I'm going to go ahead and erase a lot of this drawing, just so we can concentrate. I'm going to erase all of it, just so we can concentrate on where that angle is. So again, it's going out to A and B, which means it intercepts this arc right here. And we got that arc before. Remember that arc was 162 degrees. And remember that with the central angle, it's exactly the same as that arc. So we don't have to change it at all. It's just going to be 162 degrees. The last one in this video is number 12. They give you that XZ is tangent to a circle whose center is Y at point Z. And as soon as they say tangent, when they say it's tangent to the circle, that means at point Z you have a right angle, which they've already labeled for you. They've been nice to you, so they've already got that right angle there. Now they can tell you that YZ is a radius, that XY equals 25, so 25, whoops, not 12, 25 is going, starting from here at X all the way across into the circle there, that's 25. And XZ is 24, so this piece on the outside, and it's easier to see, but from X all the way to Z, there's 24. Now, whoops, they want you to find the circumference of circle Y. Now remember that circumference, the formula for circumference is 2 times pi times the radius, which is 2 times pi times something. So the actual work here that we're trying to do is just find what the radius is. And they told us that YZ is a radius. So this X, I'm actually gonna, I'm gonna call this R because that's the radius. That's what we have to solve for. Now, notice that it's a right triangle, and I'm going to draw that right triangle down here. That's now separate from the circle, just so we can see it without the circle. Now we're solving for our there to be able to plug into the circumference formula. And there's two ways you can do it. First is, since you have two side lengths of a right triangle, you don't have any angles, it's not going to be sine, cosine, tangent, you're not using trig, then it's Pythagorean theorem. So you could do r squared plus 24 squared equals 25 squared. The other way is if you know the triples. If you don't know what the mean, if that doesn't sound familiar to you, then you might not have learned it this year. But if you know the triples, then you'll know that 7 goes with 24 and 25. But either way, you should be able to solve this equation and get 7 as the radius. So now that 7 gets plugged in here. And then to find that circumference, all you have to do now is multiply 2 times this 7, which is 14. And you don't have to use 3.14 for pi, you can just leave it like this. So now my circumference is 14 pi.